Hello and welcome to another Algebra 1 video tutorial. In 11.2 we'll be classifying polynomials. Our goal will be to understand the basic terminology of polynomials and the classification of polynomials by the number of terms or by their degree. Okay? Recall that a term can be a single number, variable, or product of numbers and variables, and in an expression, addition or subtraction, which is just adding the opposite, is what separates terms. Okay? Polynomials are identified by their number of terms. So a monomial is a single term in which the exponent for every variable is a positive integer. A polynomial is an expression that is either a monomial or sum of monomials. And then polynomials with two or three terms are used so often they have special names. A binomial, that's a polynomial that has two terms, and a trinomial is a polynomial that has three terms, and we'll look at some examples. Alright, so a monomial, it's a single term in which the exponent for every variable is a positive integer. So something like 6x. Okay, it's one term, and it has a positive integer for the power. Negative 16t squared, that's one term. X squared y to the fourth, that's one term, so those three are monomials. Here's some that are not monomials. 6x plus y. See how there's a plus sign here? Addition separates these into two terms, so we call that a binomial. Negative 16t to the negative 2, that's not a monomial because the negative exponent on the variable. And x squared over y to the fourth, that could be written as x squared y to the negative fourth, which we have a negative exponent. So if variables are divided, that doesn't work because you really are going to have a negative exponent on the variable. All right, so a polynomial is an expression that is either a monomial or sum of monomials. So a binomial is a polynomial that has two terms. So these are binomials. X plus 26 square roots of 2, that's two terms. X over 3, because that's like 1/3 of x, minus y cubed. So there's no variables in the denominator, so it wouldn't be negative exponents. And then 0.44 minus 2 to the negative 10th, pq to the fourth. Since 2 is a number, it's not a variable, the negative 10th doesn't matter on that. That's just going to be 1 over 2 to the 10th, so a fraction times pq to the fourth. Those are both positive integer exponents. So not binomials would be 26x square roots of 2. It's all one term, so it's monomial. This one is negative xy cubed over 3. That is also a monomial. And then here we have 0.44 minus 2 to the negative 10th p plus q to the fourth. There's three terms there, so that's a trinomial instead of a binomial. And then the last thing, a trinomial. That's a polynomial that has three terms. Think of tricycle, three terms. Okay, so that would be something like 18x squared plus 5x plus 9. There's three terms there. A squared plus 2ab minus b to the 20th, so there's three terms there. And pq plus qr plus rp, that has three terms as well. Now this is a product, and there's only one term there, so it's a monomial. This one is a to the negative 2, 2ab plus 2ab minus b to the negative 20. So these two have negative exponents, so that doesn't work. Those are not trinomials. And this is 1 over pq plus the 1 over the quantity pq plus qr plus rp. Those would be the quantity to the negative 1. Variables divided, so it's negative exponent on that, so that doesn't work either. And then there are no special names for polynomials with more than three terms. All right, we could also classify them by their degree. So the degree of a monomial is the sum of the exponents of the variables in the expression. So 3x squared, that has a degree of 2. So if you add up all the sum of the exponents, there's only one exponent here, so that would be 2. 10t, that's like t to the first, so that has a degree of 1. Now this is a monomial because it's just one term of product. 15a squared b cubed c to the fourth, so it's the sum of the exponents of the variables, so 2 plus 3 plus 4, it's going to give you 9, so that's actually a 9th degree monomial there. Alright, so the degree of a single number such as 15, that's considered to be a degree of 0 because it would be like 15x to the 0. But 0 doesn't really have a degree because you could take 0 times some x to the n, where n could be anything, and we don't want n to be anything. So the degree of a polynomial is the highest degree of any of the monomial terms, so any of its individual terms, after the polynomial has been simplified. For example, if you had 6x minus 17x to the fourth plus 8 plus x squared, that has a degree of 4. Now you'd also want to put that in standard form so that you can easily see what the degree is. That's going to be the leftmost term. So the highest one is that, so it'd be minus 17x to the fourth. The next one would be a plus x squared. Then the next one would be plus 6x and a plus 8. That's what they could say standard form, so it's in decreasing power order, so the highest degree term is on the leftmost. So as you can see, this is going to be a fourth degree. Now this one where you have so this is a polynomial in x, because there's only x variable. This one's a polynomial in p and q. So if you want to rearrange it in p, you would look for the highest term. Highest term here in that polynomial with 4 terms that has the highest power of p. So I would rearrange that to p squared q cubed, and then I would probably say plus pq squared plus p plus q squared. Now if I did it in q instead, I would start with this one, p squared q cubed plus probably this one plus pq squared plus q squared plus p. But it doesn't really matter, just as long as you do it in one or the other, in p or in q. And this is going to be a fifth one, so this is the highest power term, and it has 2 plus 3, which is 5. So it's a fifth degree polynomial with 4 terms. This is a fourth degree polynomial with 4 terms. Alright, so let's try 3 more here. Classify each polynomial by the number of its terms and its degree. So this one, by the number of its terms, has 3 terms, so it is a trinomial. And what is the degree? Well, it's not in standard form. We would rearrange this to be x to the 7th plus x to the 6th plus x to the 5th. You don't have to do that, but if you do that, you would want the highest power first in decreasing order, so you can see that it's a 7th degree. Okay, this next one, there are 2 terms, so it is a binomial. Okay, and we have a 3 plus 2, so that's 5. That's not the highest though. This is a 1 plus 6 is 7, so this is also a 7th degree. So if you're putting this one in standard form, you'd have negative 40yz to the 6th plus 8y cubed z squared. Okay, and then this last one, there's only 1 term. It's the product. There's no addition or subtraction. So that is a monomial, 1 term. And there's only 1 variable because pi is not a variable, it is a number, and it is 3. So it is a 3rd degree. Or you could call it a cubic. Okay, so we can classify them by the degree. Like we were just saying, that's the degree of 3 would be a cubic. Degree 1 is linear. Degree 2 is quadratic. We've studied those quite often. Degree 3, we just said, was cubic. Degree 4 is quartic or biquadratic. 5 is quintic, and anything over 6 does not, or anything 6 and over, does not have a special name. You can also classify them with the number of the terms. We've done this already. 1 is monomial, 2 is a binomial, 3 is trinomial, 4 does not have any special names. Alright, a polynomial of degree 1, such as 13t minus 6, called linear, a linear polynomial. A polynomial of degree 2, such as this, is called a quadratic. So that's just kind of what we're talking about on the last screen. Linear and quadratic polynomials whose coefficients are positive integers can be represented by algebra tiles, such as this. The tiles here represent 2x squared, and that's because this is a x by x, so it's x squared. This one is an x by x, so it is x squared too. So that's where you get the 2 of those, 2x squared. Then you have 3x. These are x by 1, so their area are x. So that would be that group right there. And then plus 1. This last one just a 1 by 1. So that's that. Okay. We'll use this a little more coming up. Algebra tiles to represent multiplication and factoring, but that's in a later lesson. Alright, that wraps this up. Your assignment will be 11-2, page 665, 2 to 34 evens. Thanks for watching, and we'll see you next time.